Okay, so now let's discuss the homogeneous differential equations. So homogeneous differential equations are those types of differential equations where the function and its derivative can be expressed in a form such that it allows variable separable method through substitution. So we will, if we express it in a particular form, so the form is like this. After some time we will see that if the differential equation, for example this is a differential equation, it can be expressed in the form of f function y by x. So you can then brought this into variable separable method, and you can apply the variable separable method through substitution. So what you have to substitute? Y is equal to vx, where v is another function. So we will see how. So once again I will repeat it. So homogeneous differential equations are the differential equations where the function and its derivative can be expressed in a form such that it allows variable separable through substitution. For example, this is your differential equation. So if you bring this differential equation to the form such that f is function of y by x, then you can use this substitution y is equal to vx, and you can apply the variable separable method that we have seen earlier, which was our first method, which we saw in the last video. So for the illustration, let's take a differential equation. So this is a differential equation. So here this is the m function and this is the n function. So if we also have one more method to test that whether this is a homogeneous differential equation or not. In place of x you can put kx, and in place of y you can put ky. So what will happen? So if you put here x is equal to kx and y is equal to ky, so you can see the k square term will come out in the m function, and similarly in the second function also, if you see, the again k square term will come out, and this k square term is same. So it also proves that this is a homogeneous differential equation. So you can use this method also, or the method which we saw earlier, which was the most simplest one, as I think. So you can directly write the dy by dx form. So you can rearrange this equation and write the dy by dx form. So if you rearrange it, you will get on the RHS side y square minus x square divided by 2xy. And further, if you divide numerator and denominator by x square, you will get this form. So you can see that this is a function of y by x. So now you can just simply substitute y is equal to vx, and you can solve it just like a variable separable method. So we will see how. So this is just an illustration. So we will also see one problem. First, let's carefully discuss the illustration. It will help us to understand. So if you see the illustration, so you have to substitute y is equal to vx. So if you differentiate this, so it will become dy by dx is equal to v plus x times of dv by dx. So actually we applied the product rule of differentiation. Then substitute this in the parent equation, this equation. So if you substitute this, so in place of dy by dx, you have to write v plus x dv by dx. And on the RHS side, you will see that y by x can be replaced by v. So it will give you v square minus 1 by 2v. You can see this. So now further, you have to bring this on the RHS side, and this will go and become negative sign. Then if you further simplify this, so you will get v square minus 1 minus 2v square by 2v. And on the LHS side, let it as it is. So further simplifying it, you will get this form. And if you now you can see that this differential equation can be brought in the variable separable form, because this v square v function fv can be taken to this in the side of dv, and this x function, which is a function of x, can be brought in the side of dx. So you can see that once we bring both v function on the side of dv and x function on the side of dx, you can simply integrate it, and once you will integrate it, you will get this final answer. So this is your differential equation, that the final answer of your equation. So we have actually solved our differential equation, but if you can further simplify it, because it is simplifiable, because sometimes the answer is given in different form. So you can bring this minus ln x on the LHS side, sorry, and further you can apply the logarithmic formula, that is ln AB is equal to ln A plus ln B. So in reverse way, you can apply this formula and you can simply get the final answer as this. Okay, so let's solve one problem on this homogeneous differential equation. So we already saw illustration, so you can pause the video and you can try this by yourself. Okay, then let's start. So you can see here dy by dx, and this side RHS side, you can see it is a function of y by x. So here we can easily apply our like homogeneous differential equation concepts, whatever we have studied. So you have to substitute y is equal to vx. So we have seen that dy by dx then will become v plus x dv by dx. Now substituting it here, so it will become v plus x dv by dx is equal to, now here substituting y by x is equal to v, it will become sine v plus cos v plus v. So here you can see that this v and this v will get cancelled, and now your further it will get simplified, x dv by dx sine v plus cos v. So as we have seen that if you once substitute this y is equal to vx, so you will get it in the form of variable separable method. So you can see here fv function, and here this is a function of fx. So it can easily, you can do variable separable. You can bring the x function on the side of dx and v function on the side of dv. So if you see, now further simplifying it, so you can bring it like this, sine v plus cos v on one side, and integrate it. Similarly x dx by x, you can bring it and integrate here. So now if you see, what you can do here is you can multiply by 1 by root 2 and like this. So what is the benefit of this? So by this way you can actually apply the formula cos a minus b, which is equal to cos a cos b plus sin a sin b. So here 1 by root 2 is actually sine pi by 4, and this 1 by root 2 is cos pi by 4. So if you see carefully here, you will get 1 by root 2, so dv, this will become cos v minus pi by 4, and here we will get ln x plus c. So now this will become very easy to like integrate, because we know the integration, this will go in the numerator and becomes sec function, and we know the like integration of sec function is ln sec x plus tan x. So applying this over here, what will happen, you can see it will become 1 by root 2 ln, and this will give you first sec of v minus pi by 4 plus tan of v minus pi by 4, and on the this side you had ln x plus c. So finally this is your final answer. So just before submitting your answer sheet, make sure you replace v by y by x, because we have initially substituted this. You have understood this concept of homogeneous equation. So let's see the next method in the next video.